Hello, everybody. Welcome to this session about HVAC basics for home automation integrators. A topic that was of great interest to everybody that was talking to us, asking to provide some insight into the basics of how these HVAC systems work in order to get to better integration with them. So, what we are going to talk today about is basically 4 topics. 3 of them are the actual explanations of how this system work, the HVAC systems, what is the difference between different systems that you face in different projects that you need to integrate and come in with some solution to provide total automation for your customer. And of course, the integration challenges each of these impose when you need to integrate with them. I will finish, of course, this session with some recommended or products that we provide and solutions that we provide in order to enable these successful integrations. A few words about us. We are CoolAutomation. We're founded since about 13 or 14 years ago. We are based in Israel, and it's a private company. We work all around the world in more than 90 countries with thousands and thousands of systems successfully integrated with various automation and controls and monitoring systems. And the way we do that is by providing a simple and straightforward optimal solution for tight integration for controls, management, and even service of these advanced HVAC systems I'm going to talk about. So speaking of systems, what are actually these HVAC systems? Let's understand first of all what is the air conditioner, the HVAC system, how it works. So all of you definitely familiar with those good old window units that were sitting in the window, obstructing some of the view, of course, and the window would be separated between the outdoor and the indoor space. And same is the AC unit, this air conditioning unit that would have 2 portions, the outdoor side and the indoor side. So in this picture, you can see the essential parts, all the parts that actually consist of a whole system. However, there are some essential parts that without them, of course, the AC would not be the unit as you know it, cooling or heating the air in your space. So the main part, the heart of the system is the condenser. That's number 4 on this picture. This is a special device using physics and different mechanics in order to cool or heat the air. It works with the evaporator, which is number 1 in the picture, and that is already on the indoor side of the unit. This one is taking the air that goes that flows through it, heating it, cooling it, using the refrigerant or the coolant that is the condenser, the compressor is handling for it. Of course, to control all this, you are very much familiar with the thermostat, which is the device on the wall that is being used by the end user to control the system, to indicate what is the temperature of comfort that they want the system to reach. And the thermostat will actually be the interface with the user and also the one to control the AC unit to work towards the target temperature. That is the one that regulates the temperature. It senses the temperature in the space and by this indicates to the unit whether it reached or did not yet reach that target temperature. So that's how the air conditioner is built. Every air conditioner, even those smallest and simplest good old window units, all the way up to the most advanced large mechanical or very advanced systems, all of them will have these essential parts. They will not look the same, they will not be functioning the same, but the functionality, the target, the objective of each of these parts is the same. That's pretty much where it ends. So looking at these systems, I would like to address the two types of systems, two types of that you see in your project. There are the traditional systems. In the US, these are fan coils, the PTAC units that you can see probably in many hotels or offices also. And there are the bigger unit, the packaged or rooftop unit that sits on the roof, as the name implies. And these are big, or chillers even. These are large mechanical devices making a lot of noise, extracting a lot of energy for its use. So these are the traditional systems. And they have their own thermostats, which I mentioned earlier. They are located on the wall, and they sense the temperature in the space. And by this, indicating to the system whether they are about to reach or they already reached the temperature desired, and then will activate or deactivate those units in order to continue cooling or heating the space towards that target. On the other hand, there are the advanced inverter systems. These are most predominant already around the world for the last 30, even 40 years. In the US, they came in a bit later, probably a decade ago they started, and now they're going more and more and more. You can see them everywhere. These are the split systems or the splits, also VRF or VRV systems. They are bigger, but both types of systems are of inverter based. This is the main technology that is used by these kind of systems. And these systems, instead of thermostats, they use wired or wireless remote controllers. Those are the ones that, again, the end user will use in order to indicate to the system what is the target comfort temperature, humidity maybe sometimes, that they want these systems to reach. So looking at these two types of systems, the traditional and the advanced ones, there are three main differences. The communication is a big difference between the two, the refrigerant and the energy. The refrigerant in the traditional systems is usually water. These are water-cooled systems, or water is used in order to heat or cool the area. The air that flows through that water is being cooled or heated. And the energy. The traditional systems spend a lot of energy on during its operation. These are high power systems. The advanced inverter systems are communicating. They use refrigerant other than water. So this is a special liquid. Sometimes they used in the past a gas, like Freon. Today there are different refrigerants, more efficient in their energy consumption and so on. And therefore the systems are much lower in their energy consumption. But today, since we are not mechanical engineers, or we don't look at this from the HVAC perspective, from servicing this, we're looking at the integration part. And the main difference here is communication, because that is the way for you to implement those integrations. And that's what we are going to face today. This is the main challenge for integration. And the VRF and the split systems are using bidirectional communications for monitoring controls, which is the key for successful integration. Speaking of those systems, controls, and challenges, again, let's look at in more precision towards the differences between the two systems, two types of systems. The traditional systems, when you want to communicate with it or somehow to convey to that system what is your target temperature that you want to achieve, you will use a thermostat. That is the brain actually of the system. The rest of the body, which is the big clunky mechanical type of equipment, there is nothing there to think about or communicate with. So the thermostat is the one that is used for that. The advanced inverter systems are totally different in that perspective. Both the outdoor part and the indoor part both have brains, both have computers in there. Therefore, these computers can communicate. And for that, in order to communicate with them, these are the wired and wireless remote controllers that are being used in order to communicate with these systems. And these are the means for the end user to indicate to those systems what is the comfort target temperature or climate that they are willing the system to reach. So those are the main two differences. Now, when we talk about integration with systems, both systems can be integrated with home automation or building automation systems. And this is actually the purpose of this session, to look at that challenge. For the traditional systems, there are, of course, solutions. They are limited because the systems are limited in terms of what they allow to communicate and how to integrate with them. The VRF systems, the split systems, these advanced inverter systems, these are fully bidirectional communicating devices which enable full integration with your automation systems. And for that, they use Modbus communication protocols, BACnet interfaces, and even KNX, which is widely used in Europe and other places in the world. But now, recently, we start seeing KNX entering into the US market as well. Not to a large extent, but we can see some already. So when we speak about communication and controls, feedback is _1 key requirement for a properly integrated device. Because when you send a command and you don't get a feedback, that's not controls. This is a send and forget type of command. And if you don't get the feedback, maybe you as a user, but definitely you as if you have a system that needs to control it, if it doesn't have any feedback, then it never knows whether the command succeeded and what happened on the other side of the equation, what the HVAC system actually did upon receiving that command. So when you use wireless communication, it's a one-way communication. Usually, because these are infrared devices, they send the command. It's an open loop type of communication. There is no feedback. So when you press on the button saying that you need 72 degrees to reach the system to reach to, you just wait by yourself to feel whether you feel comfortable or not. The system will not tell you back that it succeeded or did not succeed reaching this kind of request and target temperature. So you will not see any event responses or error responses and so on. So this is definitely not the interface, the infrared, to implement fully automated integrated systems. Two-way communication, that's the #1 requirement. When you send a command, it's acknowledged. So upon this acknowledge, you can see if there was success. If it wasn't successful, you can retry upon that failure. You can also respond to system status that is being reported by the system towards your automation system. And therefore, you can act upon these conditions. You can program responses. You can program any activities you would take upon any kind of indication from the system what it is doing. So this is the full integration between two systems, the automation systems and the HVAC systems. And the VRF and the split systems are fully open in this two-way communication, allowing that full and successful integration. Now, I mentioned several times the thermostats and so on, and of course, today you can see some really nice thermostats like Nest, Ecobee, Aprilaire, and other vendors who make really nicely designed thermostats with the digital displays, which touch displays, and so on, and they even learn your activities, the learning thermostats, and so on. So they're definitely smart, right? Well, the smartness is in the cloud, in the devices themselves, and in the supporting systems of the vendor in the cloud to which it communicates via in the internet. It does not make the HVAC system smart. So trying to connect these devices to the already smart VRF or split system, it's not a good mix, because these systems are already smart. They don't need additional brains, okay? And especially if these are not non-native brains, they don't communicate with these VRF systems or split systems, because these are still the good old 5-wire thermostats. They maybe look nice, they perhaps have these smart features and so on, but when it comes to communication, they do not communicate to the VRF systems, to the split systems. Therefore, they will send, as in with the traditional system, a one-way command. That's a miscommunication. There is no feedback. They will not report you any errors, and you will never know from through the thermostat whether the VRF or the split system succeeded in this requirement. There are solutions for that. Of course, why I'm mentioning it, because the vendors of the VRF and the split systems, they do provide some special interface devices in order to connect from 5 wires into 2-wire communication with these VRF systems, but they are not communicating. These are simple on-off commands, which are kindly actually miss the whole point of full communication and take the advantage of the and the benefits of the functionalities of the VRF and the split systems. So it is really not recommended to use the 5-wire thermostats, even though they're nice and smart looking, unless you have a good integration solution via the cloud or other more smart means with the VRF system, not the hardwire special adapters. Now, when we talk about projects that you face, you need to understand in which projects you will find which types of systems. So in small projects and even medium-sized projects, you will find the split systems. That means you will have the outdoor unit and the indoor units that you see on this slide, the way they look like. They are nice looking. Some of them are even concealed, the ducted or the cassette types of systems. You know, they're hidden away, and all you see is the grill through which the air is flowing. Okay, and on the wall you will have a wired or wireless remote controller. Both will help you to control these systems. The wired thermostat, or you would call it thermostat, but this is just the interface, will send and commands and also show the statuses of the system. In larger projects, you will see already the VRV or the VRF systems. These are also made pretty much the same way, but look a little bit different, especially on the outdoor unit. Outdoor units will be larger, will take more space, of course. Not necessarily will make more noise. Both types of systems are quiet, very quiet. Indoor units will look pretty much the same. Also will have a set of wall-mounted or ceiling-mounted floor-standing units, and also ducted or cassette systems, and the same controls, pretty much like the split systems. So when we talk about the project, you will first of all know what kind of system. So these are the 4 main questions that you need to address when you come to face a project. What is the system? Where is it located? Who will be using it? And how they will be using it? So the first part, what is the system? Is it a mini-split, multi-split, or a VRF system? Is it a heat pump or heat recovery? Now, in this terminology, you have to understand heat pump is a simple system that, of course, everything is relational. It will allow either cooling or heating the space. It cannot operate in the same time. Let's say in one room it will be heating, in the other room it will be cooling. Either the whole system is cooling, either the whole system is heating. So that's the big thing. Also, and the heat recovery system, that is really the most advanced and most expensive VRF system. That will allow to have in one area could be cooling conditions, and in another place could be heating by the same system. Okay, that's basically what you need to know. It's a mini split or a VRF, it's a heat pump or heat recovery, and whether maybe there is a BAS or BMS system to integrate with. Anyway, the magic word is to ask from your HVAC contractor or whoever has installed the system is the equipment list. The equipment list will show you exactly what is in that facility, what is being used, what type of systems, the model numbers, the quantities, and the next thing will be interesting, where is it located? Important thing is to know the layout and the design of the system according to the facility. Is it a private home or a multi-dwelling unit with multi-residential condos or so on? Maybe it's a hotel or an office. Is it a retrofit? Is it a new build? And so on. So this is, it will have implications on how the system is laid out and how it is designed in terms of where are the units located and what is the distances between them and so on. Now, all this is not for the purpose of the systems to integrate between them, it's for the purpose of the actual end user. So who will be using this? Is it a family use? Are these employees in an office? These are guests in the hotel and so on. Is it a shared or directly owned resource? Shared meaning, is it in an office? Or if it's a owned resource, each apartment has its own little AC or maybe its own requirement to control only their own units. And definitely the important question would be, what are the end user devices to be used? It could be the device that is provided by the vendor and will be sitting on the wall that wire the remote controller. Maybe the users want a remote app on the phone, on the computer. Maybe they want to change the controlling devices to devices that can control these systems that will look differently than the native device. So these are the questions of who will be using that and what means they will be willing to use in order to control the HVAC system. And then the question of the application itself, how they are going to use it. That comes from the devices, from the previous question, what devices will be used? Are these tablets? Are these mobile phones? Is there an app? Is it integrated into the overall automation solution? Maybe sometimes the user want, if it's a high-end home, they want clean walls. They want, because there is a design perspective. So they would say, we want the thermostats or the control devices to be hidden, maybe in a closet or something. So all these things are defining the user experience requirement and the expectations of the end user. So when asking these main 4 questions, you actually map the whole requirement of the project in order to understand the specifications, in order to implement them by the means of integration we're talking about. Now, when we talk about the requirements, eventually all this investment in equipment, integration, and all these efforts to make all this, these systems work and talk between them, is for one purpose, the comfort of the end user. So the climate in their space will be to their comfort. Here comes another big difference between the newer systems and the traditional systems. The traditional systems, if you recall, there was the thermostat that was measuring the temperature inside the space, and wherever it was sitting, that's pretty much the area it was sensing the temperature at. The newer systems, that the split systems, the VRF systems, they have several measuring devices. One, of course, is the one on the wall. It has its own sensor and it measures the temperature wherever it resides. However, there are additional sensors. The indoor unit has also a sensor and it measures the return air temperature. So the system, when it's deciding whether it reached the target temperature, it makes some averaging and makes some calculation in order to compare between the return air temperature and the sense temperature on the wall. And maybe there is also a remote sensor that is being used. Also important, it will provide even more precision. But the idea here is that you can reach a much more precise ambient temperature. Precision is key here because compared to the traditional systems, the VRF and the mini splits, the multi-split systems, are very precise in reaching the target temperature. And that is one of the reasons they use so many sensors in order to reach the temperature. So, and by the way, as I mentioned earlier, sometimes the customer might require a clean wall. So the thermostats or the controllers have to be hidden. That means there will be sensing the space temperature in the place where they're hidden, in some closet. You definitely don't want that. That is the case where you will be eliminating or canceling the measurement on the controlling device, on the wired remote controller, and you will be installing a remote sensor. Maybe it's not you, of course, the HVAC contractor will come in and do that, but that will provide you the ability to measure precisely and where you want the temperature in order to reach the target climate requirements as close as possible to what the customer requested. So to summarize this, when you have a project, whichever size it is, it's important to understand what are the specs of that project, which means you get the HVAC system equipment list, you know what are the model numbers, what is the make, what is the system layout, how it is designed, where they're located, how many units you have, because all this will come into the overall target to reach the integrator to focus on customizing the solution in order to satisfy the user preferences and to define different user profiles in order to reach that precise integration for the best customer satisfaction. And for that, we provide and help with integration using our products. There are, of course, other solutions, but here we talk about the challenges and how we help resolving them by our devices. So when there is a communication challenge, we would come in with some kind of interface device that will help using these devices in order to reach the target benefits. And the usage issues here that come into your projects are of different perspectives. Other than what we mentioned earlier, you have to understand also which are the brands, what are the types of systems, and how you want to integrate with them. So the brands, you probably heard these names, Daikin, Mitsubishi, LG, Samsung, Fujitsu, Gree, and few others. Also the US brand names like Trane, Carrier, York, all of them use rebranded systems. For example, Trane is using Mitsubishi, Carrier is using Toshiba, JCI, York uses Hitachi, and so on. So basically all of these are of the same origin. They might be rebranded, but basically these are the same systems. But it is important to understand that sometimes several brands come into your project. Sometimes it's a retrofit, that there is already an existing system in place that the customer would not disconnect or throw away. So the new HVAC system will be just an add-on to the existing one. So you will then have to integrate with two types of brands two types of systems. How you do that? There are solutions, and we have a solution for that because we are a universal type of devices. That's what we do. There could be also different types of HVAC systems. Not all the systems that you will face will be always VRF and multi-splits. Sometimes, again, the customer would have an existing rooftop or package unit, and the expansion or the add-on will be by adding a VRF or multi-split system. We can address that as well and still consolidate the controls and integration into one system. So for your systems, for your automation devices and processors, you will be able to integrate with different types of systems through our solutions as if you were integrating with just one, regardless of the make and regardless of the type. Additionally, sometimes the customer would want to have some nice looking new things like Amazon Alexa or Google Assistant for voice controlling the systems. We can provide a solution for that as well. So how we do that, all these solutions? So we have three types of hardware interface products, and our products and solutions look like this. The one in the middle, that's the flagship, if you will. It's called the CoolMasterNet. This is the universal device in order to connect the VRF system of any kind, any make that I mentioned before. All the brands, we support them, and we provide a single, agnostic to the brand type of interface towards your automation system in order to provide a tight and precise integration, plus some cloud capabilities that can be added either by using our cloud or using an API to communicate, but I will talk about that. Another type of hardware that we provide to integrate with is CoolPlug and the CoolInkHub set. That is another type of device like the CoolMasterNet, but it is targeted at the mini and multi-split systems in order to provide those devices with their capabilities to integrate with your automation system. They are a little bit different, they communicate a little bit differently, that's why we have these devices. They're also smaller and cheaper compared to the VRF systems, hence the smaller and cheaper set of these devices called the CoolPlug and the CoolInkHub. In terms of functionality, the interface will be the same, the integration will be the same. Actually, even the same drivers are used by the home automation vendors in order to communicate with our devices. The COOLINKBRIDGE is a device that we have in order to control and to communicate with the non-VRF and non-mini multi-split systems, the good old traditional systems. That's how we implement the integration with different types of systems when you have a hybrid type of a project. So if you look at the CoolMasterNet, how it will look like, you will have a VRF system that you will see here on the left side of the slide. There is a communication with them, with these outdoor units, and you can see the brands on the different logos in the lower part of the screen. The CoolMasterNet will communicate natively by the native protocol of these different brands, and it will be able to communicate also to the home automation different brands. And you can see some of the logos that we placed here of vendors who support CoolAutomation. All of these have native drivers. So the Crestron, Control4, Lutron, Savant, Elan, and many other home automation brands have a CoolAutomation driver that you can get for free from them and just use to integrate and have a native communication between your system and the CoolMasterNet, which will then interpret and provide bidirectional communication between the VRF system and your devices. Additionally, if you prefer to use automation system, building automation systems, and you can see the logos over here, that will be using BACnet or Modbus communication, maybe even KNX. We can support that as well, either by IP or by serial communication. In a similar fashion, we would have the CoolPlug and CoolInkHub set. This one will work a little bit differently because each CoolPlug will go into each indoor unit of the multi-split system. Then the CoolPlug can communicate with the CooLinkHub by either wired or wireless communication. Then the CoolPlug, which will be sending its commands back and forth and getting commands from the CooLinkHub through this wired or wireless communication. The CooLinkHub can support up to 10 CoolPlugs in such a project. So if you have more, you can just multiply these sets. The CoolInkHub will then operate exactly like the CoolMasterNet towards your automation system, be it one of those home automation vendors that I mentioned earlier, Crestron, Control4, Lutron, and so on, or even implement a BACnet or Modbus interface towards the automation system. In terms of communicating with non-inverter based, the traditional systems, we have the CoolInkBRIDGE, which can be used to integrate with the fan coils, with the package units, with even with the underfloor heating and radiant heating to control different zones and so on. And then all of them also can be consolidated towards integration with home automation or building automation systems in the same fashion like the CoolMasterNet or the CoolPlug and CoolInkHub. So this way we will enable those hybrid type of integrations. When it comes to the installation, these are easy to install. There is no programming to do. The only programming you will need to do is on your automation system side. Once you use the driver provided by the vendor, Crestron, Savant, Control4, again, all of these, you will then just use that in order to bring those points into your automation system in order to program and plan the controls and how to act upon feedback from the systems, because this is, again, a bi-directional communication. So this is pretty much towards the HVAC system. It's just a plug and play. You just connect two wires. Usually it's two wires to the outdoor unit, or the cool plugs, also usually with two wires into the indoor unit. And that's it. Nothing to be done there. All you need to do now, usually by Ethernet to the local router, connect to your processor and start implementing the programming into your automation system. So it's much simpler. You don't need to chase the HVAC contractor for those indoor unit mappings and names and so on. You can already get all this inside your protocol. So this way you would enjoy all the benefits. You will first of all have the bi-directional communication, which is imperative for the proper integration. You would be able to integrate with different brands or different types of systems, which means you need to program only once. You need to create only one type of code in order to talk to the CoolAutomation device. From that point on, the CoolAutomation device will communicate with the HVAC system on your behalf and will convert those native commands into the commands and controlling functionalities that you already implemented by doing it once with our device. And of course, you can integrate the smart devices, like I mentioned earlier, for voice control, and maybe other thermostats like Ecobee, for example, that is also cloud-based. That can be also implemented to improve the user experience with the HVAC system. And the way it goes, you have the HVAC system on the left side, you have the automation system on the right side, you have some smart devices, all of them can be connected using either the CoolMasterNet or the CoolPlug or the CoolInkBRIDGE, or a combination between them, depends on the requirement of the project. Okay, and for that, of course, you can contact us. We will advise on how to do it, what to apply, what will be the optimal solution, and we will provide one of our solutions from our offering that we provide today. So basically, when you look at this, this is the chain that you would see. There is the VRF or some kind of AC system on the right side. We have our own cloud. We have a suite of applications. One of them is for service. The other ones are for controls, remote control, for facility management we are going to introduce very soon. All this will provide you with the ability, first of all, to integrate with your home automation system or building automation system. And with the cool plugs and so on, you can connect also the multi-split systems, the indoor units of those AC devices. In the same way that I explained earlier. And additional, if you have additional systems to participate in that climate objective to reach the convenient and comfortable climate, there are different sensors, there are different other systems that participate in this, like radiant heaters and so on. We can integrate all of them. Just talk to us. We will explain how it works and how to do it. And if you have any cloud or maybe third-party integration devices that you want to integrate via, let's say, our API, we can provide that as well, because sometimes you might want to do something custom made and not to use the native or maybe other brands off the shelf that are available for you. So there are also the API possibilities that we provide in order to integrate with us, with our system, and then on with the HVAC systems. This pretty much covers the whole offering that we have today. Of course, we are working on more and more and more, and we're providing updates on that. And I will summarize that if you have a project, get those specs, get that understanding what is required. Talk to us. We will provide some kind of idea of how to address this in the best and efficient way, using our products and the experience and the expertise and the know-how that we collected after so many years and so many units being successfully integrated across the United States, of course, and in the world. So we are here for you. I hope that this session helped you understand a little bit better what it is, the HVAC system of nowadays, and how it is possible to integrate with it. Simply, it's not scary. It's really straightforward, and we are here to help with that. So thank you for your attention, and goodbye.